Okay, stats. This is day 7. They just told me, though, Mrs. Olson told me that they're wanting to have your grades submitted by Monday. So I'm going to combine day 7 and day 8 video together so you guys can finish this packet and get it all turned in so we can get grades turned in. And then you won't have a video to watch on Monday. So it's going to be maybe a little bit longer. You should still have time to finish doing what you're doing. With these last 2 days, but we're going to do 2 days in one just so that we can get done and you can submit this and get grades all turned in so you can graduate. So day 7, or the second to last day, is hypothesis testing, and this is just using one sample. So if you want to put that on here, one sample or one set of data. In day 8, we're doing 2 sets of data. So this is where we have like P1 and P2, or X bar 1 and X bar 2. This is 2 data sets instead of 1 data set. So similar process, but just doing 1 data set versus 2 data sets. Really the main thing that's going to change is how you calculate your test value. Okay, so let's go through and let's, when we're doing proportion, mean, standard deviation, 48 is going to be a proportion, 49 is going to be a mean, and 50 is going to be a standard deviation. Okay, so we'll kind of talk through those. Let's talk about our variables over here when we have our equation. So n is going to be the number in your sample. P hat is going to be the sample proportion. Okay, so like they'll ask for, like here, the proportion of students that were born in the last 6 months of the year is going to be my P hat. Okay, we'll go through and do that here in a second, but they're talking about like the data that you're given, the proportion that you're looking at. P is going to be the population proportion. And this has to go with like what you're claiming. Okay, so like down here, we're claiming that the majority or more than 50%, this is going to be reflected with the value of P. Okay, it's what we're judging against, or what we're claiming. Okay, Q is going to be the opposite of P. Opposite of P. And then your fish value is your significance level. Okay, and in this case, I think most of them are 0.05, but they might, no, this one's 0.05, and for standard deviation, 0.05 as well. So I might have used 0.05 all the way through for each one of those. Okay, when we get down to mean, make sure that when you're doing mean, you're using the T table, and standard deviation you're using the chi-squared table. So these guys are going to be on the same chart, but front and back. And then the Z table, what you're using for that one is the positive negative score. Whoop. Let me go back. Positive negative score, you're looking at this like bottom corner. That's going to be the number that you're going to be looking off at the Z table. Okay, and that tells you what your cutoff values are on your bell curve, to tell like what's considered to be an extreme value and not. Okay, so for mean, when you're doing X bar is going to be your sample mean. Let me do that in a different color. Sample mean. Sample mean. Mu, which is this guy right here, mu, he is the population mean, and that is the mean that you use that comes from the claim. So if we're claiming something, let's see what we're claiming down here. We're claiming to test the claim that the mean pulse rate of all Blue Hill seniors is 70. This is going to be your mu value, okay? To test the claim that, there you go. All right, N is the number in sample. Okay, S is the standard deviation of your sample. And then your significance level for your fish value. Okay, that's going to be the stuff that you use in your equation to solve for T. Your chi-squared, this guy, N is the number in your sample. Okay, S is the sample standard deviation. Okay, this guy is going to be your population standard deviation. So that's your sigma, the circle with the hat on him. That's going to be the one from your claim. Okay, the population always has to do with what you're claiming, what you're comparing against. Okay, and then this is the significance level, which on all of these is 0.05, I've just said. Okay, so let's go down to the standard deviation one down here. To test the claim that the standard deviation for pulse rates is less than 10. So you're doing sigma is going to be compared to 10. Okay, for your hypothesis, this one is less than 10, but your sigma that you're using, first one's always going to be equal to, and then the second one, in this case, you're doing less than 10, and this is what we are claiming. So I'm going to put my claim next to that. Now that will tell you that he is only a left-tailed test, so all 5% is going to go here. And then you will have an imaginary 5% here. So you are looking at 90% on the chart, okay? All right, I'm not going to do the rest of that for you. You need to calculate your test statistic and figure out where your, I don't know, I guess it should be on this side, is if it lives here or if it lives here, to which one of these you're going to circle. You'll need to calculate that value and then circle, answer this question right here, answer this question, and then answer this question. Make sure that you fill out both of those for each problem. Answer this question, okay? Answer this one, and answer this one. Make sure that you will do that, okay? Let's go through on number 48, and let's do this whole guy so you can get your thoughts together. 48, for your hypothesis, okay, we're looking at P because we're doing proportion. So we start with P equal to and then P whatever, either less than, greater than, whatever. We're talking about to test the claim that the majority, which means more than 50%, so greater than 50% or greater than 0.5. That's what my hypothesis is going to be, and my claim is going to go with the bottom. Okay, if we're doing greater than, we only have one tailed test, and it's going to be on the right side, and my significance level of 5% goes here, and I have an imaginary 5% that goes over here to make him symmetric, so I have 90% in the middle. Okay, I'm going to do these all with the critical value method. We did the p-value method a long time ago, where like p-value method was 0% here, 100% here. This would be like 95%, right? And like figuring out where he fits. I'm not going to do that method. I'm going to do the other one, the critical value method, because we're going to go off of this chart. If we're looking at 90%, my cutoff mark is 1.645. So I'm going to go this route, 1.645. Then all I need to do is find the value of my test value from this equation and figure out where he lives in comparison to that 1.645. Okay, so that's what I'm going to do right now. I'm going to write him over here. So using this formula, I've made a mess of this page already, sorry. Hopefully you can decipher this. So I want p hat minus p, okay, and then the square root of pq over n. Okay, let's go through and fill in our paragraph here for what we have and what we need. The proportion of the n equals, we have 14 students, so I'm going to put 14 in that spot, okay, that are born in the last 6 months of the year. Last 6 months of the year. I'm going to go to my data, which is down here, I think, and I've circled them. The last 6 months of the year would be December and August and September and December and August and August and August. We got a lot of them. I think that's all of them. Okay, that is 1, 2, 3, 4, 5, 6, 7 out of 14. Hey, which makes it really nice. P hat is 7 out of 14, which is 50%, right? 7 out of 14, if you need to write that in there. 7 out of 14 equals 50%, 0.5. So our p hat value is 50%. We are comparing that to a p-value of 50%, okay? So are we saying that 50% is equal to 50% or 50% is greater than 50%? Now, I understand that 50% is equal to 50%, so I'm guessing that what I'm going to end up doing is circling that top one. But is it 50% just for our data, or would it normally, if we do a bunch of data, would it normally be greater than 50% is what we have to come up with a conclusion. So I know that for my data, it actually is 50%, but if we would have used a different set of data, would it actually give me the conclusion that it's greater than 50%? That's what we have to decide, okay, using the equation. Is it more than 50% enough or whatever? So I'm going to go over here to my equation. Okay, let me zoom out. We have p hat minus p. P hat is that 0.5. 0.5 minus 0.5. Okay, the square root of p is 0.5. Q is also 0.5. Okay, over n, which is 14. Now, I don't even need a calculator to do this because I can see what's going to happen. If you take 0.5 minus 0.5, I get 0 on the top. It does not matter what this number is down below. 0 divided by any number is going to be 0. So my z value is 0, and I'm going to compare to where does it live? Does it live there or does it live in the shaded region? Okay, if 1.645 is my number here, then 0 is going to live right there, which means that we're going to circle this one and we're going to cross this one off. It is not greater than because it's not in this region, right? So he is going to be equal to 50% and not greater than 50%. So I'm going to fail to reject the null hypothesis. Circle that one. The claim in this case is false because we are claiming that it is greater than 50%. So explain what this conclusion means in your own words. We are 95% confident that to test the claim that the majority of Blue Hill students are born in the first half of the year. We're 95% confident that, I'm just going to say that the majority of BH students are not born in the first half of the year. I'm just like restating what we were testing the claim of, but putting my conclusion in there. So we concluded that it was not a majority. So majority of students were not born in the first half of the year. You know, there's how that works out. Okay, so using that same method, go through and do 49 and 50, but you're doing a mean and a standard deviation. Keep in mind that you're going to have to use the t-table, not this guy, because you're not using, or you only use that for proportion. Okay, all right, let's go down and let's do day 8 stuff. Okay, I've got day 8 already to go. I think 2 data sets. Okay, so we're looking at p hat 1 and a p hat 2 is what we are comparing. Okay, so 51, the proportion of, I don't know, do I need to go through and fill these out? I don't know, maybe not. Maybe not. Yeah, I don't know. P hat 1, P hat 2, those are going to be your 2 samples. P bar, I guess I didn't write in what P bar is. Okay, put over here. Maybe we need to include P bar. P bar is the pooled value. So P bar is x1 plus x2 over n1 plus n2. So maybe I need to say that. Okay, there we go. All right, for P bar, I think all the other ones have the same variables. It's just you have 2 of them now, like S1 and S2 are the 2 different standard deviations that you have, okay? All right, so 51, the proportion of we still have 14 students in this class that have heights above 6 feet. Okay, so we're talking about heights above 6 feet. Let me go to the table. How many people have heights that are above 6 feet? 6 feet is 72 inches. So I went ahead and circled them. Height above 62 inches is Jake and Clayton and Cray and Marcus. They're all above 72 inches. I think that is all for heights, okay? We're going to also compare that to wingspan above 6 feet. So 72 inches here would be Jake and Clayton and Cray and Marcus. And that is all. So we're comparing like basically the same people against each other. You know, every once in a while you'll have one person trickle in, like Emma was close with her wingspan above, 6 foot. She's got like 1.5 inches to go, something like that. But every once in a while, these 2 columns will not have the same number in them, and that's what makes it more interesting to compare. This one's kind of boring, I guess, because we have the same people in both data sets. So we're doing heights above 6 foot. There are 4 out of 14 that have heights above 6 foot, which is a 4 over 14 is, let's go 0.29. Okay, same thing with wingspan above 6 foot is 4 out of 14, which is also 0.29. And what I'm saying here for our claim, use a significance level of 0.05 to test the claim that the proportion of students with heights and wingspans above 6 foot are the same. So we're saying that P1 is equal to P2, okay? Or P1 is not equal to P2. Sometimes they'll say greater than or less than, but this one's just a not equal to, okay? And when it's not equal to, we're going to have 2 tails. Okay, when we have 2 tails and we have a significance level of 5%, that means we have to split it and put 2.5% here and 2.5% here. okay, which means we have 95% in the middle, all right? And if we have 95%, and I go to my chart right here that I'm going to use for proportion, 95% is 1.96 is what I'm going to label my bell curve, okay? All right, and that's going to tell me, okay, 1.96 and negative 1.96, okay? And then we have to do our equation here and figure out where he lives inside of here and then draw a conclusion from there, okay? So, which one does my claim go with? To test the claim that the proportions are the same. So we are claiming the top one. Okay, claim is going with that they are the same, all right? So when I do my test value, my stupid little giraffe over there is taking up all the room to do my stuff. Anyway, whatever, okay? All right, this guy right here, we have to calculate the z value. So z equals, I have p hat 1 minus p hat 2. All right, so here's the deal. P hat 1 is 0.29. P hat 2 is also 0.29, okay? The bottom, we have the square root of all of like these numbers over 14 plus these numbers all over 14, okay? P bar is this guy, okay, and x1 plus x2, that would be like 4 plus 4 over 14 plus 14, right? I had 4 people in one category for height, 4 people for wingspan over 14 plus 14. So that is 8 out of 28. And some of you guys are like screaming at the TV right now because you're like, quit doing all that work. Like, look at this. If I have 0.29 minus 0.29, that ends up being 0, and it doesn't, just like the first one, just like the top problem. It doesn't matter what this number is down below here, 0 divided by a number is going to be 0. So I really don't even have to calculate this bottom part. That was kind of exciting. 0 is going to be the value for z, okay? Now we have to decide, where does he live on the bell curve? 0 is going to live right here, okay? So does that mean we're going to circle this one or circle this one, right? If he lives in the middle, that means he's not on the extreme ends. That means he's not equal to. So we're going to circle this one. He is equal to, he's in the middle. Okay, so we are going to fail to reject the null hypothesis, just like we did in the first one, but this time the claim is true because our claim is going with the top one. So explain what this means in your own words. We are 95% confident that the proportion, I'm just going to go off of here, to test the claim that the proportion of students with heights and wingspans above 6 foot are the same. That the proportion of, I'm going to say all BH students with heights and wingspans above 6 foot are the same. Let me read that again. We are 95% confident that the proportion of all Blue Hill students with heights and wingspans above 6 feet are the same. The proportions are the same. Yes, that is what we are concluding. Okay, so that is the first problem done. You have to do 52 and 53 using those formulas for that. Make sure you are paying attention to what they're asking for. Fill in the blanks and it will help you a lot. You're doing mean height, okay? And again, those means I have at the bottom, okay? Like you're using the average number for, where did they go? Right here. You're using these averages and standard deviations down here. So that's what you'll use for those bottom two problems, okay? So there you go. Day 7, day 8, do those both together. Get your packet turned in. I'll get grades done, and then you can graduate. Congratulations. Goodbye.